We meet the NASA scientists who repaired a spacecraft from 15 billion miles away. The Voyager One is known for being the first spacecraft to go beyond our solar system.
Space exploration has become an important part of human interest since the 1950s, when the Soviets launched the first artificial satellite, Sputnik-One, into space. In 1977, Voyager One was launched into the cosmos and has ever since traveled further than any other spacecraft while giving us more details on our solar system. However, recently, Voyager One has sent a potentially worrying broadcast, which has been intercepted by NASA, who are trying very hard to decipher the message. Will NASA be able to unlock the mysteries contained within this broadcast? What dreadful news may Voyager One bring back? Join us as we discuss the looming consequences of Voyager One's message. Voyager One. Voyager One, a space probe launched by NASA on September 5, 1977, is part of the Voyager program designed to study the outer solar system and interstellar space beyond the Sun's heliosphere. It was launched 16 days after its twin, Voyager II. Communication with Voyager One is maintained through NASA's Deep Space Network, which facilitates the receipt of routine commands and the transmission of data back to Earth. As of August 2024, Voyager One is an astounding 164 astronomical unit, which is approximately 24.5 billion kilometers or 15.2 billion miles from Earth, making it the most distant human-made object. During its journey, Voyager One conducted flybys of Jupiter, Saturn, and Saturn's largest moon, Titan. NASA prioritized the exploration of Titan over Pluto due to the moon's substantial atmosphere, which made it a more compelling subject for study. The probe provided unprecedented insights into the weather, magnetic fields, and rings of these gas giants, and delivered the first detailed images of their moons. Voyager One's extended mission, shared with its sister spacecraft Voyager II, focuses on identifying and studying the regions and boundaries of the outer heliosphere and exploring the interstellar medium. On August 25, 2012, Voyager One made history by becoming the first spacecraft to cross the heliopause and enter interstellar space. 2 years later, it experienced a third wave of coronal mass ejections from the Sun, further confirming its position in interstellar space. In 2017, the Voyager team successfully fired the spacecraft's trajectory correction maneuver thrusters for the first time since 1980, extending the mission by an additional 2 to 3 years. Voyager One is expected to continue transmitting scientific data until at least 2025, with a potential maximum lifespan extending to 2030. Its radioisotope thermoelectric generators may provide enough power to return engineering data until 2036. What surprising glitch caught the attention of the space engineers on Earth? Launch and trajectory of Voyager One. There would never be a complete discussion on a rocket launched into space without actually discussing how it was launched and the problems it encountered. The launch of the Voyager One probe was rather difficult to witness, as it had some nerve-wracking moments for the engineers who developed it. Let me paint you a perfect scenario. Imagine standing on the edge of history, witnessing the launch of a spacecraft that would journey farther than any human-made object before it. On September 5, 1977, Voyager One blasted off from Cape Canaveral aboard a Titan IIIe rocket, embarking on a mission to explore the outer planets. Just 2 weeks earlier, its twin, Voyager II, had taken off. Yet Voyager One, despite its later start, would go on to reach both Jupiter and Saturn sooner, a rather mind-blowing feat. How did it overtake the Voyage II, which had been sent 2 weeks earlier? It seems like an entertaining cosmic relay. Voyager One's launch was far from flawless. The Titan's second stage, the LR-91, shut down prematurely, leaving 1,200 pounds of propellant unburned. In the world of rocket launches, it can be compared to having your car engine sputter when you're about gaining speed while on the way. But here is where the brilliance of engineering shines. It would seem that the engineers had prepared for the worst, and what a preparation it turned out to be. The Centaur stage pushed the spacecraft even harder, slowly extending its burn just long enough to make up for lost momentum. It was a rather close call, as they were only 3.4 seconds from running out of fuel entirely. Can you imagine if the engine had failed? Voyager 1 might have missed its shot at exploring the giants of our solar system. This delicate dance of timing and precision ensured Voyager 1 could speed ahead on its shorter trajectory. Jupiter was in just the right position when Voyager 1 launched, giving it a gravitational boost. But what if the stars had not aligned so perfectly? Would Voyager 2 have been the one to make history instead, considering that it was launched 2 weeks before? I guess we would never really know. Some of Voyager 1's groundbreaking discoveries. Nonetheless, it seems rather important to understand what the Voyager 1 is actually used for and how much it has affected human knowledge of what space looks like. For example, the Voyager 1 discovered Jupiter's moon, Io, a discovery that would have slipped out of human grasp and comprehension if the Voyager 1 wasn't in play. It was revealed by space engineers and experts that the Io wasn't just a moon on Jupiter, but a world that was engulfed by serious volcanic activity. The spacecraft took a breathtaking image of the Io, revealing a substantial amount of volcanic activity taking place on it and showing materials being launched into space as a result. This discovery was a big game changer and needle mover for people who are NASA engineers and for other people who just have serious enthusiasm for space matters. This discovery changed our outlook on the geology of planets, especially amidst the volcanic activity in and around the solar system. Jupiter's moon wasn't the only discovery that the spacecraft made. It also discovered a feature that had never been seen before on Saturn's ring. In 1980, Voyager 1 conducted a flyby of Saturn, revealing that the F ring is composed of 3 narrow rings, which initially appeared to be intricately braided. It is now understood that the outer 2 rings contain knobs, kinks, and lumps that create the illusion of braiding, while the less bright 3rd ring lies within them. Furthermore, the data collected by Voyager 1 suggested that Titan, Saturn's largest moon, might have water underneath its surface. With the possibility of this discovery, hopes were aroused regarding the existence of life, or at the very least, conditions that could let life exist beyond the surface of the Earth, the significance of these findings, and the importance of Voyager 1's mission. The spacecraft has not only offered humanity vital insights into faraway worlds, but has also significantly improved our understanding of the solar system. The current malfunction, on the other hand, poses a risk of disrupting this exceptionally vital task. There's been a significant malfunction in the flight data system, which is essential for the operation of the spacecraft. The flight data system of Voyager 1 is an intricate network of components that are meant to ensure that the spacecraft operates without any hiccups. The primary computer, the data storage, and the telemetry systems are all components of this system. Therefore, anytime there is a problem with any of the components, engineers are forced to find a way to ensure they find a solution so that the spacecraft can continue on its voyage. Surprising glitch. A significant problem with the flight data system of Voyager 1, widely considered to be one of the most renowned space missions, recently brought the spacecraft into the public eye. On December 12, 2003, the National Aeronautics and Space Administration reported a serious problem involving the spacecraft's systems. It was discovered that the flight data system of Voyager 1 had malfunctioned. 3 essential onboard processors had begun transmitting ambiguous binary data. The data, which consisted of a string of ones and zeros, was incomprehensible to the engineers working on Earth. They just couldn't make any sense of it. Immediately after the problem was discovered, the engineers working for NASA were able to transmit commands to Voyager 1 and confirm that its systems were functioning properly. However, the data that was being delivered was still incomprehensible, indicating a significant problem. An early approach from NASA was to attempt to restart the system, a rather common practice among engineers and just about everyone else. If it's not working, simply restart it. They did this in the hope that a clean slate would be sufficient to resolve the issue. Regrettably, this strategy did not prove to be successful, and Voyager 1 continued to transmit the same nonsensical data. Over the course of several months, engineers from NASA have been developing and testing a variety of potential remedies to the issue. Every single attempt they have made to restore communication to normal has been largely unsuccessful. What next for NASA now? While it seemed like things were not looking up for the engineers at NASA despite their professional efforts to set things right, a silver lining represented itself when one of their numerous solutions started to show some promise. The cause of the glitch. The flight data system is where the problem that is now occurring with Voyager 1 can be found. Its role as the spacecraft's central nervous system is responsible for coordinating and organizing the numerous subsystems while ensuring that everything functions appropriately throughout the spacecraft's exhaustive journey. The problem in the system has made it impossible for NASA to obtain useful data from Voyager 1, which may have an effect on the ongoing scientific research and discoveries that are being made after months of hard work. Specialists are coming closer to determining what caused the recent problem with Voyager 1, which has been attracting a lot of attention. This in-depth research not only demonstrates how challenging it is to manage antiquated equipment in the harsh space, but it also brings to light the extraordinary intellect in preparation. NASA engineers have pinpointed the cause of a communications breakdown between Earth and Voyager 1, the interstellar explorer. It appears that a small portion of corrupted memory in one of the spacecraft's computers is to blame. This glitch, located in the flight data subsystem, is what caused Voyager 1 to send unreadable data back to Earth. The flight data subsystem is crucial as it packages the probe's science and engineering data before it is sent to mission control via the telemetry modulation unit and radio transmitter. The issue began to reveal itself when Voyager 1 operators sent a poke command to the spacecraft on March 3, 2024. This command was designed to prompt the flight data subsystem to send a full memory readout back to Earth. The readout confirmed to the NASA team that approximately 3% of the flight data subsystem memory had been corrupted, preventing the computer from carrying out its normal operations. Launched in 1977, Voyager 1 became the first human-made object to leave the solar system and enter interstellar space in 2012. After 11 years of interstellar exploration, on November 2, 2023, Voyager 1's binary code, the computer language it uses to communicate with Earth, suddenly stopped making sense. The zeros and ones that previously conveyed data became meaningless. NASA's engineering team suspects that the glitch is the result of a single chip in the affected portion of the flight data subsystem memory ceasing to function. This failure could have been caused by a high-speed energetic particle from space, or simply the wear and tear from 46 years of service, which sounds rather plausible. 46 years of roaming in space is no mean feat, even for a machine. Voyager 1 is currently about 15 billion miles or 24 billion kilometers from Earth. This means it takes 22.5 hours to receive a signal from it, and another 22.5 hours for the spacecraft to receive a response. Despite the challenges, NASA scientists and engineers are optimistic that they can find a way to help the flight data subsystem operate normally, even with the unusable memory hardware. Resolving this issue could take weeks or even months. However, if successful, Voyager 1 should be able to resume transmitting valuable scientific data from beyond the solar system. Eureka! The NASA engineers. Find a solution. The spacecraft, which has been exploring space since its launch in 1977, began transmitting garbled data to Earth in late 2023, puzzling scientists and engineers. The issue was traced back to a small portion of corrupted memory in the spacecraft's flight data subsystem, which is responsible for packaging and transmitting the probe's scientific and engineering data. To diagnose the problem, NASA's Voyager 1 team sent a command to the spacecraft on March 3, 2024, instructing it to provide a full memory readout. The readout confirmed that approximately 3% of the memory had been corrupted, preventing the system from performing its normal operations. This corruption caused Voyager 1 to send back telemetry that was incoherent and unusable, effectively cutting off the flow of critical scientific data from the spacecraft. The root cause of the memory corruption remains uncertain. It could have been triggered by a high-speed energetic particle from space, or it may simply be the result of the memory hardware aging after 46 years in service. Despite the exact cause being unclear, NASA engineers are optimistic about finding a way to bypass the corrupted memory and restore the subsystem to normal functionality. The successful identification of the problem is a significant step toward resolving the issue, but further work is required to ensure Voyager 1 can continue its mission of exploring interstellar space. NASA's team remains committed to restoring full communication capabilities with the spacecraft, which continues to provide invaluable data from the edge of our solar system. NASA engineers devised a rather genius plan to address the corrupted memory issue in Voyager 1's flight data subsystem by breaking down the affected code into manageable sections and relocating them to different parts of the memory that didn't need it. This approach required careful reconfiguration to ensure that the code would still function as an integrated whole. The team also needed to update any references within the flight data system memory that pointed to the original locations of the code. The first step in this meticulous process was to isolate the code responsible for packaging the spacecraft's engineering data. On April 18th, NASA transmitted this code to its new location within the flight data system memory. Given that Voyager 1 is located over 15 billion miles or 24 billion kilometers from Earth, radio signals take approximately 22.5 hours to reach the spacecraft and another 22.5 hours for a response to be received back on Earth. When the mission team received confirmation from the spacecraft on April 20th, 2024, the results were positive. The modification had worked successfully, allowing NASA to check the health and status of Voyager 1 for the first time in 5 months. In the weeks that followed, the team planned to continue relocating and adjusting the other affected portions of the flight data system software. This careful process would eventually enable Voyager 1 to resume transmitting scientific data, allowing the spacecraft to continue its mission of exploring interstellar space. The success of this approach highlights the dedication and ingenuity of NASA's engineering team, who continue to overcome the challenges posed by operating such an aged spacecraft at the farthest reaches of human exploration. However, is this the first time they have had problems with one of the twin spacecraft? Let's find out. Voyager 1's exit from the heliosphere. On February 14, 1990, Voyager 1 captured the first family portrait of the solar system from its vantage point outside the system, including the iconic image of Earth known popularly amongst space geeks as the pale blue dot. This term somehow helps one keep a record of how small we are as people when our planet seems as infinitesimal as a dot in space. A reality check that keeps us in order. Shortly after this historic photo, Voyager 1's cameras were deactivated to conserve energy and resources, and the spacecraft's camera software has since been removed. This makes it challenging to reactivate the cameras, and the Earthside technology to process the images is no longer available. How then can they solve the dilemma? It was not an easy choice, but it's either you conserve energy or keep taking pictures to send back to Earth at every opportunity, even though some are not really worth exploring. By February 17, 1998, Voyager 1 had traveled to a distance of 69 astronomical units, AU, from the Sun, approximately 6.4 billion miles or 10.3 billion kilometers. This surpassed Pioneer 10 as the most distant spacecraft from Earth. Traveling at a speed of about 17 kilometers per second or 11 miles per second, Voyager 1 holds the record for the fastest heliocentric recession speed among spacecraft. As it continued its journey toward interstellar space, Voyager 1's instruments remained operational, allowing scientists at the Jet Propulsion Laboratory to use its plasma wave experiments to search for the heliopause, which is the boundary where solar wind transitions to the interstellar medium. By 2013, Voyager 1 was traveling at a relative velocity to the Sun of about 61,197 kilometers per hour, or 38,026 miles per hour. With this velocity, the probe covers roughly 523 million kilometers, or 325 million miles per year, translating to about 1 light year every 18,000 years. For a machine that nearly failed to launch, NASA engineers are surely quietly loving their luck, considering that Voyage 2 hasn't outshone Voyage 1 despite the 2-week gap. The irony of a cosmic relay. Voyager 2. Back in August 2003, the space engineers at NASA thought they were going to lose touch with Voyager 2 forever. It was as if, by some miracle, communication has been re-established. In a calculated move to conserve energy, NASA has been forced to turn down a fair number of probes on the Voyager 2. According to a recent report, Voyager 1 is only using 4 out of its 10 instruments, while Voyager 2 is still using 5 of them throughout its operations, which seems a little weird when you consider the fact that it was launched first into space before Voyager 1. However, Voyager 1 is the first of the duo to reach the interstellar region of space, which is surveying space from around the stars. In a desperate bid to keep the lifespan of the Voyager 2, a rarely used component of the spacecraft like the heater was turned off. Consequently, they reduced the load on the spacecraft to amplify the functions of more important components, like the high-gain antenna, which is used for communication to Earth. Despite the cunning applied by the space engineers to reduce the load on the spacecraft, there is still an expectation that they stop actually working in 2025. While they hope it outlasts that period, they have no guarantees. However, for Voyage 2, there remains an outside chance, though it still remains to be seen, that it might last a while longer. NASA believes that even if science data won't likely be collected after 2025, engineering data could continue to be returned for several more years. The 2 Voyager spacecraft could remain in the range of the Deep Space Network through about 2036, depending on how much power the spacecraft still had to transmit a signal back to Earth. Importance of the magnetometer. While NASA has tried using load management by shutting down some of the instruments of the probes, the magnetometer remains an actively functioning part of the Voyager twins, the magnetometer. This instrument has been a key player in the scientific discoveries made by the Voyager twins as they continue their journey through space. The magnetometer, despite the challenges of deep space, remains a vital part of both Voyager 1 and Voyager 2, allowing them to continue unraveling the mysteries of the cosmos. The magnetometer aboard the Voyager probes is essential for measuring the magnetic fields encountered in space. It records the magnetic field of the Sun and the other planets too. As Voyager 1 and Voyager 2 ventured beyond the planets and into the more distant regions of the solar system, the magnetometer began to pick up on a phenomenon that has intrigued scientists for decades: solar winds. Solar winds are streams of charged particles released from the upper atmosphere of the Sun, known as the corona. These winds are not just gentle breezes, they are powerful gusts of energy that extend throughout the solar system, influencing the space environment. The magnetometer picked up the discovery of solar winds in 2015. From discovery, it has been stated that the solar winds can exert an influence on magnetic fields even beyond the heliopause, which is the limit. In addition, both Voyager probes make use of low-energy charged particle detectors with which they discovered the heliopause. What is the heliopause? Importance of the Hydrazine engines, micrometeorite shields, and optical calibration. The Hydrazine engines on the Voyager probes have been critical to their success in navigating the outer reaches of our solar system and beyond. These small yet powerful engines, also known as thrusters, are responsible for controlling the orientation or attitude of the spacecraft. It burns very exothermically in the presence of oxygen or oxygen-containing compounds, generating a lot of hot gases, which can be used to produce the exhaust thrust for a rocket. They allow the probes to make precise adjustments to their trajectory and ensure that the scientific instruments on board can be accurately pointed toward their targets, whether it be a distant planet or a region of space beyond our solar system. The Hydrazine's engine helps the probes to be maneuvered in space and also maintain their temperature. On the other hand, the micrometeorite shield is used to protect the instruments located in the back of the spacecraft from dust and debris in space. Imagine an object floating through the vast expanse of space with all of its instruments out in the open. The possibility of a compromise is far too great to risk. This shield is crucial for the long-term survival of the Voyager probes as they travel through space, where even tiny particles can cause significant damage. The Meteorite shield is designed to absorb and deflect impacts, ensuring that the delicate scientific instruments on board remain functional. As the probes venture further into the unknown regions of space, the Meteorite shield continues to play a vital role in protecting the mission's integrity. Without this shield, the Voyager probes might have been compromised long before reaching their current record-breaking distances. However, there is a popularly raised question that threatens the credibility of the information that we are being fed from space. How do they ensure that the information that we get as feedback from Voyager 1 and Voyager 2 is real? Well, that is where the age-old optical calibration technique comes in. The optical calibration system that is still in operation by matching the sensors of each probe with a target plate on a regular basis guarantees that the sensors receive accurate readings. Throughout the course of the extensive mission, they have carried out this calibration procedure numerous times, strategically ensuring that the images received are not tampered with at all. It is common knowledge among space scientists that these calibrations are needed for continuing to collect reliable information from space. Despite the fact that a lot of other instruments have been turned off, several of which have been turned off for decades, scientists remain convinced of the quality of the data they collect from space via their probes. Future of the Voyagers. When human curiosity is combined with superior technology, then there are no limits to what humanity can achieve. Every signal that is received from these distant messengers provides us with new insights about our own world and whatever might be lurking beyond it. Not only have the Voyagers been helpful in studying the vast expanse of the cosmos, but they have also resulted in improvements in different technological facets. In recent times, newly constructed spacecraft have been equipped with autonomous systems that are able to exercise decision-making authority without waiting for a decision from Earth. Additionally, more advancements have been made in their communication systems. Their end game is to make sure that they can stay in touch with these new sets of spacecraft over enormous distances. Imagine not having to consistently lose communication with your spacecraft for a long time, unlike what happened in the past with Voyager 2, with most NASA engineers feeling that they might have lost it forever. The Voyagers seem to have ushered in a breath of fresh air and ideas to secure the future of subsequent spacecraft. These developments have created a new sense of belief in NASA and their partner, the Artemis Accords, showing them a way forward to their ultimate goal, which is to send some astronauts back to the Moon using the Artemis program, which is one of their ultimate endeavors. The purpose of this program is not just simply landing people on the Moon, but to actually create a permanent presence on the Moon. Their objective is to have an established base on the Moon, which could take them one step closer to actually exploring Mars. Artemis will prepare the missions on a longer trip, if need be, for one to help set a proper tune for their eventual journey to Mars. Also, Mars Sample Return is another significant project that is being carried out by ESA, the European Space Agency, in conjunction with NASA. The main purpose of this mission is to collect samples of rock from the surface of Mars and bring them back to Earth afterwards. These samples, they believe, have the possibility to offer information about the geology and the environment of Mars, as well as the possibility of determining if life ever existed on the Red Planet. The mission requires the use of numerous pieces of equipment and different spacecraft, and requires a number of complicated tasks, such as landing on Mars, collecting samples, and then being launched back to Earth to do direct research on another world. Voyager 1 and Voyager 2's impact on the development of space exploration can never be overstated. Despite having to contend with antiquated materials and the extremely difficult conditions of deep space leading to breakdowns in systems and problems with communication, these errors have been catalysts in the development of new missions. Do you find space exploration intriguing too? Let us know in the comments. Did you enjoy the video? Show some love by liking, sharing, and subscribing. Click the video shown on your screen to watch another of our interesting videos.